Hi, this is Tim with Tim's Training. Today we're going to talk about VAV and pneumatic controls. What we have here is our demo unit set up, a fan connected to a normally closed VAV box. We've got pneumatic thermostats and a velocity controller. And this is set up to be a pressure independent configuration because of the velocity controller. In a previous training we talked about how to set up a velocity controller and how to calibrate a thermostat. Today I'd like to focus on something a little different. What I'd like to do is introduce to you today a new thermostat for pneumatic controls. This thermostat is made by Millennial Net. Quite different. As you can see, this has a digital display and it has buttons. It operates like a standard thermostat. We have main air in and branch air out. But if you look at the back, everything is digital controlled in this thermostat. This thermostat can act like a regular programmable thermostat, even though it's a pneumatic controller. You can set this up to be standalone control. You can program it with time of day, occupied, unoccupied, with setback temperatures. You can also, let me show you the operation. Right now, the ambient 79 degrees. I'm going to increase my set point to above ambient to call for heat. If you notice I've got a PE switch simulating my heater, and as we look in our display right here we have a little flame indicated, so it is going to call for heat. And my heat simulator has now come on. So I'm going to drop my set point now to call for cooling. And we will notice, if I have a little magnet helix set up, if we look at our pressure, we will notice our airflow will increase and our heat will cut off to transition this from heating to cooling. Our differential pressure is increasing as our flow is increasing. We're calling for cooling, so we're opening up our valve, our air valve here, as you can tell by the increasing pressure. And that pressure will continue to rise until it's at its maximum adjustment from our Cruder controller. All right, now that we have demonstrated the operation of this thermostat, let's talk about where this can be used. Any place that you use a standard pneumatic thermostat, that thermostat can be replaced by this thermostat. Why would we want to do that? Well, why do we ever convert these pneumatic systems to DDC control? It's to save energy. We save energy by having time of day scheduling and setback points. This thermostat can do that without the necessity, the time, the expense of gutting all of our pneumatic controls. We can accomplish our DDC control through this thermostat. This thermostat operates standalone, or it can communicate with other thermostats. So you can install one thermostat or you can install 250 thermostats, whatever you need to do the controls. If you have multiple thermostats, this thermostat operates off a mesh network. What that means is each thermostat has a radio and it acts as a repeater for other thermostats. You can take your existing controls that talk Modbus or BACnet, translate that signal and talk directly to each and every thermostat. You can do individual time of day controls. You can give full control, zero control, or give them 3 or 4 degrees of adjustment to play with. It's strictly configurable either at the thermostat itself or through the backnet capable DDC controls. This concludes this session of Training with Tim. If you would like to have further instruction on any product or control, drop me a line in comments. I'll see if I can put together a video and post it online. Thank you for your time. This is Tim Chambly, Stromquist, Atlanta.
If you need to control it or measure it, Stromquist & Company has a control solution for you. With over $2 million of inventory between our Georgia and Florida locations, an easy-to-use online ordering platform, same-day shipping, and a factory-trained team of controls experts to answer your questions, Stromquist & Company continues in its tradition of offering great service and great products.